All right, so today we're going to talk about z-scores. And what we can use z-scores for is for, first off, normally distributed data. So remember that means it kind of fits in our normal curve. And what happens if, what's that mean? Our data is not exactly 1, 2, or 3 standard deviations from the mean, okay? What z-scores lets us do is it lets us help find how many standard deviations above or below the mean is. So a z-score, again, is the number of standard deviation a value lies above or below the population. So once you find the z-score, you should also have a z-score table that was passed out as well. And what that does is that tells you the probability of getting a certain z-score. Now, we do have a formula for a z-score, and it will be given to you on your assessments, which is z equals x minus mu over lowercase sigma, where x is a data point. So this is the data point that you're looking for. Mu is your mean of your population. And lowercase sigma is the standard deviation of the population. All right, so problem 1, in a given population, the weight of newborns are normally distributed with a mean of 3,250 and a standard deviation of 500. What is the z-score of a baby weighing 2,500 grams, and what does this mean? All right, so A. We'll find our z-score. So our data point is 2,500 minus the mean of 3,250 over the standard deviation of 500. So when we do this, we should get negative 1.5. So this means a baby weighing 2,500 grams is 1.5 standard deviations below the mean. Now we're going to do a little bit more with this problem because really, even though this tells us how many standard deviations below the mean is, that's what our z-score tells us, our z-score can give us a lot more information. So if you look at the table, what we're basically finding is if our mean is 3,250, and we're looking for 2,500, our z-score table tells us this value here, or the probability of getting less than, having a newborn weigh less than 250. So what we're going to do is we're going to find this on our table. And what you're going to want to do is look at the negative version. So remember, we just found that z equals negative 1.5. So the first column is your first two decimal points. The row is your second decimal point. So we're looking technically at negative 1.50. So I'm going to go down to negative 1.5 and then over to 0. Which should give us this value here. And you can kind of see the way that it's shaded as well. So 0.668. So we get that, according to our table, our area is 0.0668, which means that 6.68% of newborns weigh less than 2,500 grams, because we're shading to the left. If I wanted to find out what percent wear more, I would just do 100% minus that. All right, so I'd like you to actually pause this video and try B. See if you can get B. So go ahead and pause. All right, go ahead and check your answer. So here we should get the z-score, gives us 2.5. So 4,500 minus 3,250 divided by 500 equals 2.5. So this means a newborn weighing 450 grams is 2.5 standard deviations above the mean. So when I draw my normal curve, I've got my mean of 3,250 and my 4,500 is above the mean. So if I'm trying to find out the area to the left, I can look at my table. And I want to make sure I look at the positive side. So 2.50 is 0.9938. Which means that 99.38% of newborns weigh less than 4,500 grams. All right, C, what is the probability that a newborn weighs between 2,270 and 4,230 grams? Use z-scores of weights and the normal curves. So here we're trying to find the probability, which is what we just practiced. So here we were technically only asked for what's the z-score. This one means we definitely need to use our table to find our probability. All right, so what we're going to do is we're going to find a z-score for both of those. So for my first z-score, 2,270 minus our mean of 3,250 over our standard deviation of 500 equals negative 1.96. And I'll do the same thing for our other value, 4,230. So when we calculate this z-score, we get positive 1.96. So now what this one is doing is it is looking for our standard deviation between these two. Excuse me, it's looking for the probability between these two. So what we're going to do is we're going to find the probability of both of them on our table and end up subtracting them. Because this one's going to give me my probability to the left, so this tail area. And this one's going to give me the probability to the left of it. So when I subtract it, I'll subtract this tail from the whole thing to just give me the area between. So I'm going to find negative 1.96 on our table. So we make sure we look for a negative 1.96. So I'm going to go down to negative 1.9 and then over to 6. So I get 0.0256. Excuse me, 0.0250. So 0.0250. And that's what this area is. For positive 1.96, we'll do the same thing. So look at the positive, 1.9, and then go over to 6, so 0.9750, 0.9750. Which represents this whole area. So we are going to subtract these two. So 0.9750 minus 0.0250 gives me 0.95 or 95%. So there's a 95% probability that a newborn weighs between 2,270 and 4,230 grams. All right, so suppose SAT scores among college students are normally distributed with a mean of 500 and a standard deviation of 100. If the student scores a 700, what is her z-score? So for this one, you're just going to find the z-score. So go ahead and try this and pause the video once you've got it. All right, so you should get 2 as your answer. In the United States, the average IQ is 100 with a standard deviation of 15. What percent of the population would you expect to have between 90 and 120? So since I just did one like this, I'm going to have you do this as well. So first, I want you to find the z-scores. So pause the video and find the z-scores. And then I want you to unpause the video. All right, so check these z-scores. Make sure you got them. So what we're doing is we're looking for our probability between these two. So if our mean is 100, 90 to the left, 120 to the right, we're finding this area between these two. So go ahead, pause, find the area, look at your table, and find the area of each of these, and then subtract them. So pause the video and try that for me. So our final answer we should get is 0.6568. If you wanted to write this as a percent, you could have also wrote 65.68%. I'm going to go ahead and skip problem 3. I'll write down the answer if you're interested at the end of the video. So problem 4, a calculus exam is given to 500 students. The scores are normally distributed with a mean of 78 and a standard deviation of 5. How many students scored above a 70? So first thing we want to do is find the z-score of 70. Actually, for our picture, I'll draw our picture first. What this is asking is if the mean is 78, how many scored above a 70? So we are shading to the right here. And we're going to find out first the area or the probability, and then we'll multiply it by the 500. So our z-score would be 70 minus 78 over 5. Which is negative 1.60. So now when I look at my table for negative 1.60, this one's in the way. Negative 1.60 is 0.0548. But notice that's the area to the left. Your z-score table will always give you the probability of less than. So this area is 0.0548. And we want the to the right. So what we're going to do is 1, which is 100%, minus this probability to the left. So 0.0548, which would end up us 0.9452. So 0.9452, or 94%, scored above a 70. So out of how many? I'm going to do 0.9452 times 500. Which gives me 472.6, or approximately 473 students. All right. And that is it for these notes for today. And here's that last problem that I said I'd work out at the end to show you. So if you want to pause the video and copy it down.